Hello everyone, today we are going to be talking about the topic of camber optimization. So far we have discussed about what is camber and the effects camber can have on cornering of the vehicle and the side effects of camber, which is camber thrust and aligning torque because of camber. Today we have to talk about a concept called camber optimization. For example, when we talk about negative camber, we know that negative camber helps us in gaining more lateral force when we are making a turn. So for example, consider this wheel to be a left wheel on a car which is inclined negatively 5 degrees in this direction. Now when this car is making a right turn, because of the weight shift whenever we are making the right turn, the force will be transferred on this direction, on this wheel. Therefore this negative camber will help in moving this wheel like completely vertical, and therefore we'll have more tread on the road, which will help us gaining more grip and therefore more lateral force when we are turning, which is very essential, right? But it's not practical to just give any random number of negative camber value. Like if negative camber helps us in making a hard turn, then the question arises, why don't we give like minus 50 degrees of negative camber, right? And therefore we can do more hard turns and we'll have more tread laying on the road when the weight transfer happens, and that will be helpful in cornering, right? But no, it doesn't happen like that. Obviously there are many reasons which we have discussed in other videos for side effects of the camber angle, but so far in this video we are going to be talking about the camber optimization topic, because it doesn't essentially happen. Minus 50 degrees was an exaggeration, but for example, if we go from minus 5 degrees to minus 15 degrees, just taking as an example, then a pattern has been noticed. Like if we see in this cornering graph, which is lateral force versus slip angle, we have seen it many times. You see this black line, this essentially is the graph of lateral force versus slip angle when we have 0 degrees of camber, when the tire is perfectly straight. Okay, you have graph looks like this without any camber angle. And then for this wheel, right, when we have negative camber, and this is the outside wheel, right, left wheel on a car which is making a right hand turn, so the weight is shifting on this wheel and this tire gets itself vertical and has the perfect tread on the road. In that case, we'll have this graph, the green graph, which starts from a higher position, and then after the linear range, the lateral force value starts to drop off for the higher degree of slip angles. So this is one of the reasons why we need to optimize our camber angle, what negative degree of camber angle we want to have in our car, because we obviously don't want to lose the grip, and we want to make sure with all the weight of the vehicle and all the other suspension characteristics which we are going to discuss in later videos, like how much of the lateral force we will be needing to make a turn for whatever application of the car is at this much speed. So this is one of the factors that need to be considered. However, also look at this dotted black line. This essentially tells us that if we had negative camber, like this wheel, negative camber, but if there was no roll off, so lateral force will still be higher at higher slip angles compared to the wheel at 0 degree of camber. But in practical life, what happens is the green graph, that is after the linear range, the lateral force value starts to drop off for that slip angle, unlike the 0 degree. Obviously it's not going, even for the 0 degree camber angle, the value doesn't keep on increasing, it drops off, but not as much as one for the camber angles. The red graph is for the other wheel, for the right hand wheel. If you are making a right hand turn, if this is the right hand wheel and it's inclined negatively, like negative direction, negative camber angle, negative 5 degrees, and we are making a right hand turn, then the weight will be shifted on this wheel, on the left wheel, this one, and this one will go further down, like it might go to minus 6 or minus 7 degrees. So then we'll have less of a tread lying on the road, and therefore less of a tendency to generate lateral force. So therefore this graph essentially represents the lateral force for the right hand wheel, right? But the question arises, why the graphs start from over here? Like, okay, we get it, negative camber helps in generating more lateral force, but essentially that should mean that it should start from 0 and should have a steeper curve either way, right? No, this is because of this concept called camber thrust, which we have studied already. When we have negative force, that camber thrust actually helps in generating lateral force, which helps in additional lateral force, right? Camber angle also provides a camber force, which acts in help in generating that lateral force, which helps in cornering. So that's why we have this amount of force even at 0 degree of slip angle. Even when we are not turning, there is a tendency of the wheel to provide us force in that particular direction. This wheel will have a tendency to go in this direction. So that's why we have two graphs like this. I hope you understood the concept, and if you have any questions, comments or concern, then leave down in the comments and I'll see you all in the next video.